So hello everyone, in this video we will be solving another LeetCode problem, and the problem name is minimum number of operations to make all array elements equal to 1. So let us read the problem statement. So you are given a 0 indexed array nums containing positive integers. Now you can do the following operation on the array any number of times. So select an index I such that it is between the range of the array and replace either nums of I or nums of I plus 1 with their GCD value. In the end, we need to return the minimum number of operations to make all the elements of num equal to 1. If it is not possible, then we need to return minus 1. So the problem statement is pretty much straightforward. Take two adjacent elements, whatever their GCD is, either remove the ith element or remove the I plus 1th element to their corresponding GCD value. In the end, we need to return the minimum number of operations to make all the array elements equal to 1. If it is not possible, we need to return minus 1. So the problem statement is pretty much straightforward. So how will we solve this problem? So first of all, what is the scenario where we will not be able to convert all the elements to 1? Or in simple words, we can say what is the scenario where we need to return minus 1. So let us see that first. Now if you have some set of numbers, you keep taking these GCDs the continuously first of these two elements, whatever their GCD is with this elements, whatever their GCD is with this element, whatever their GCD is with this element, so on and so forth. Now what you will observe that your GCD value will always decrease. So what we can say, we can initially try out to take the GCD of this entire array. Now whatever GCD that we got should be equal to 1. If it is equal to 1, that is for sure that we will be able to convert all the elements equal to 1. That is for sure. Then we need to find the minimum number of ones. Now if the GCD of this entire array is not equal to 1, then in no means we will be able to convert all the elements equal to 1. So in this scenario we need to return minus 1, because if we are not able to get the GCD of entire array equal to 1, that means we will not be able to convert each and every element to 1. So in that case we will be returning minus 1. So this was one step of the question that we have just solved. Now how will we be able to get the minimum number of operations if we are able to generate the GCD of 1? Let's say we have some set of numbers 2, 6, 3, 1, 4. Now what is so special in this array? In this array, the one thing special is that there is one present. Now if there is one present, then GCD of any number with 1 will give you 1 only. So that means it is for sure that we will be able to convert this entire array into ones. Now what is the minimum number of operations? So let us just check. We will first convert this element to 1. Then we will convert this element to 1. Similarly, then we will be able to convert this element to 1. Then we will be able to convert this element to 1. So in total, how many operations that we got? We got 1 operation, 2 operation, 3 operation and 4 operations. So yeah, in this case, we got 4 operations. Let us take some other scenario. 2, 1, 3, 1, 4, 4, 6. Here we have 3 ones. So let us see how we will be able to convert all the elements to 1. So first we will take GCD of this, we will be able to convert it to 1. Then we will take GCD of this, we will be able to convert it to 1. Then we will take GCD of this, we will be able to convert it to 1. Then this we will be able to convert to 1. Then again we will be able to convert this to 1. So in total, how many operations we took? We took 1, 2, 3, 4, 5. We took 5 operations. In this case, we took 4 operations. So what is the common thing in both the scenarios? Here we have total number of elements as 5 and we have 1 present. So the number of operations would be 5 minus 1 equal to 4. Here we have how many elements? 1, 2, 3, 4, 5, 6 and 7 elements present. And total number of ones present are 2. So we can say that the total number of operations or the minimum operations we need is 7 minus 2, 5. So this was the second part of the question that we have just solved. So if an array contains 1, that means we will be able to convert the entire array to 1, and the minimum number of operations to do that is nothing but number of elements minus total number of ones. This would be the answer. Now we have only one case remaining if all the elements are non-ones. In this case, that is the first example. So in this case, how we will do? Let us see with this example only. So this is the first example. Now in the beginning of the question, when I just completed the reading of this question, I just told you that the GCD value keeps on decreasing. So can't we try out each and every possible sub-array, that whether this particular sub-array has GCD equal to 1 or not? If we are able to make any sub-array whose GCD is 1, then for sure we will be able to convert all the elements to 1, right? So can't we check each and every sub-array, this, then this, and so on and so forth? How many sub-arrays are there? Can't we just check out each and every possible sub-array? And the smallest sub-array that we get whose GCD is 1, can't we say that if we are able to make that particular sub-array's GCD equal to 1, then we'll be able to make entire array equal to 1? Because if we are able to make one sub-array whose GCD is 1, that means we have one element which is containing 1. And if we have 1 present in our array, then we will be able to convert each and every element to 1. Can't we do that? Yes, we can do that. And since the constraints of these questions are very low, we can try out each and every possible sub-array, that whether this particular sub-array GCD has 1 or not. And whatever sub-arrays has the GCD equal to 1, we will take the smallest one and try to make all the elements equal to 1. So let us see how we will do this. So let us take the array to be something like this. I am not taking the actual element, I am just showing you the approach or the intuition for this particular scenario. So let us say that we have an array and we have element arranged in some manner like this. So let us say we found the smallest sub-array whose GCD is 1 is this particular sub-array. Now the number of operations required to make this GCD equal to 1 is what? First with this element, then with this element. So how many operations required? 2, which is nothing but the length of sub-array minus 1. Now what is length of sub-array? If we are iterating with the help of j and I pointer, so j minus I plus 1 would be the length of sub-array and minus 1. So indirectly we can say that the number of operations required is j minus I. Now if we have, let's say, converted this element to 1 because their GCD was 1. So let's say we converted this element to 1. So now in total how many operations will be required to make all of these elements equal to 1? We have already discussed this scenario. The number of ones present, total number of elements minus number of one present. So how many elements are present? N elements are present. And how many ones are present? 1 is present. So in total we'll be requiring n minus 1. So in total how many operations we did in this particular array? First to make the first one, that is j minus I, and to make other elements equal to 1 after we get 1, that is n minus 1. So in total our answer would become j minus I plus n minus 1. So this was the intuition behind this problem. This is pretty much easy problem. Just there are multiple scenarios for minus 1, if there is 1 present or if there is no 1 present. So there are many scenarios, so that's why this problem becomes a little bit tricky to understand, and we need to try out other edge cases as well. So yeah, this was about the approach of this problem. So let us see the code now. So this is the code. First we have taken the num size or the total number of elements as 1. Then we are counting the number of ones present in our array. If we get a number of ones to be greater than 0, that means the total operations we need is n minus total number of ones. That is simple. Then what we are doing, we are simply checking if there are any sub array by which we are able to make GCD equal to 1 or not. If we are, then we are taking the smallest sub array. So yeah, starting from I as the left pointer, we are keep moving with our j pointer, so on and so forth. Then we are incrementing our I pointer. For this particular I, we are checking all the sub arrays. It is a simple 2 for loops for generating all the sub arrays. and we are keep on taking the GCD of the particular subarray. If we got the GCD equal to 1 for this subarray, then we are trying to minimize the length of the subarray, because we want to minimize the number of operations. So whatever minimum subarray we got, we are taking what we can say, we are computing the minimum number of operations. So what will be the minimum number of operations? The length of subarray minus 1. What is length of subarray? J minus I plus 1. Minus 1 is what? J minus I. So we are just computing or comparing with J minus I to minimize our number of operations. After finding the smallest subarray, we can just return the number of operations, total number of operations. That would be what? Number of elements minus 1 minus number of ones. Since in this case we'll be only able to convert 1 to 1, so n minus 1 plus the number of operations required to make this particular 1, that is nothing but answer, which is nothing but corresponding J minus I. So yeah, in the end we'll be returning this. But in case if we are not able to make GCD equal to 1, in that particular case we are just returning simply minus 1. So I hope you understand this problem. So thank you for watching.